So let's move on to problem number 4. And this says what would happen to the block in number 4. We meant number 3 if you push it with 5 newtons. So the maximum static friction is 10.8 newtons, which means this is how much we need to get it started. So if we only push with 5, that means it's not going to move. Now, let's talk about what happens to the block if you pushed it with 15 newtons of force. Since 15 newtons is bigger than 10.8 newtons, it will move. And by the way, I wanted to say one more thing. If I'm pushing with 5 newtons of force and it doesn't move, that means in this case, this is the maximum static friction. In this problem, if I'm pushing with 5 newtons of force, my current static friction is 5 newtons of force as well to balance the pushing force. Just wanted to say that. Now, just to go back to number 5 now, what happens to the block if I push with 15 newtons of force? If I push with 15 newtons, well, that's bigger than 10.8 newtons. It will move. And just to kind of overkill this, the kinetic friction force is going to be 0.02 times the normal force, which we got before, which is going to be 50 times 9.8. And it's going to be it's going to be 0.2 times 490. And that's going to end up giving me a kinetic friction of 9.8 newtons. Just to put that out there. Now, what would you do if you wanted the block to be able to sustain a larger force before moving? I don't know. Put it on, like, pavement. Like, look at that, 0.8, 0.9 for dry pavement and wet pavement. So that should be the solution to those.